Okay guys, let's start the module 2 first of all, and before starting that I'll ask some questions regarding to the last class. Do you guys have any kind of doubt related to module 1 or something, any kind of doubt, the basic intro or anything related to HCF? Okay, I think so there are no doubts. If you have any doubt, you just raise your hand and you can proceed further. Right, so okay, I'll open this camera. Okay, so just a second, I'll log in with my mobile also. Okay, yeah. Okay, guys. So today our topic is about. Okay, nice. Leave it. Topic we'll cover today are ML pipeline and Scikit-learn basics. Okay, most of you don't know about this machine learning pipeline, and might be somebody knowing sklearn or Scikit-learn. All right. So sorry. All right. Okay. Anyone? Sorry, I forgot the flow. Anyone can guess what is pipeline means? Anyone volunteer? Okay, connection to something. Anyone else? That is connection. Okay. Anyone else? Sara, Zoeba, Ashwarya, Aniket, Hansika, Akshaya, Shivam. Anyone? What does a pipeline word means in a raw layman language? Okay, we'll proceed now. We don't have too much time because today we have a lot of things to cover, and might be we have to add the extra content we will be pushing to the next class. So basic pipeline means this pipe and some line. So this is the connection with the pipe and a line. Many of you might can think like this way also, but it's not like that. It's more like this, a pipeline. How actual pipeline look? What does it do? Like who told? Divya told right now. Okay, connection between two things. All right, but what does happen in that connection? Ki some of the data flows from here, from the initial point, and goes to some of the external or terminal point, or to reach somewhere else. Means something is getting produced somewhere, and you're deploying it to somewhere else in the real world to solve some problem, a sort of this. That is a technical pipeline. You can say क्या कहते हैं, definition. So you can see this machine learning engineering. In that, what is a data pipeline? Not data pipeline. Machine learning pipeline stands for. What actually it means कि you are just getting the data, like my cursor is visible, right? So getting this data and doing the exploration, what is the basic ADA part, data analysis and profiling it and whatever, wrangling, cleaning, and then pushing the data into test and train, what we discussed yesterday, that model engineering, model evaluation, model package, like training a model. If right now, no need to worry about what this term means. If you are interested, you can go and check it. But the basic meaning of the model engineering is nothing but how the data is structured and how the data is getting stored to a, what we say, machine learning algorithm, what we have selected for our training the data, and which of the features are important for it and how it works. That is the model engineering. And model evaluation means okay, whatever our model is being trained now, we have to evaluate does it work good or bad or something like that. So for that, model evaluation part comes under. And model packaging is okay, now we have, you can think of like making dosa. For dosa, you need batter. Once the batter is done, you cooked it or you baked it on a tawa somewhere. After that, that tawa is there. No, once it get cooked, like is it partially cooked 50%, 80%? That is model evaluation, okay, based on the taste and everything. Now you need to send it to parcel or courier to somewhere else, or to some Bill Gates or some Sundar Pichai wants to eat that dosa. So what you do, you will do the packaging part. Packaging you can't send like in an open, right, open plate. You have to pack through multiple, what we say, bowls, chutney and all, blah blah. That is model packaging. How you can create a format where people can check this or use that. So we do a package in the form of pickle file, ONNX and jar also. The most common is PKL, that is pickle file. And then we do through, that is the model first of all. And after that, just we send it to the real world and where it is getting deployed. The basic integration means like adding it to some website or some app or somewhere. And once it get deployed, it gives you the live monitoring. Okay, how is your the model what you have trained is actually working. If you guys don't understand right now, I'll explain it again in the one note. And what is this feedback? Feedback, I think so in third semester you will learn about feedback something in COA, Computer Organization Architecture. Over there will be a feedback. What does this means? No, okay, this model have seen something in the real world. Now it is getting back the data. This is the current data based on the how the model was performing over there. And now again the model gets trained on the same data. All right. So do you guys want me to explain it in more depth or you guys got it? If you have any doubt, raise your hand. Huh. Anyone have doubt can raise your hand. Right now I'll explain because this is the basic part if you are gonna further for ML ops, ML operations. Anyone? Any kind of doubt what is a pipeline means? Further I have more slides, so if you have doubt you that will be clear. Okay. And feel free to ask doubt in the personal chat, in the group chat, or you can mail me. I won't reply though, but you can try. So after that, there is the concept of pipeline. The basic definition is building a structure like systematic workflow that automates the process. See, there are four words I bolded. That is process of building, training, and deploying ML model. That is ML pipe. That's it. Means what we have to do, we are just doing creating a workflow. Like there was a pipeline, no, that was doing pushing some oil from one country to another. That is the same, creating a workflow that automates the process. Automates the process of what? Building. What is building? We are building machine learning models. Right now I showed you this left part. Okay, over here, this part is the model making. This still here, the yellowish part and the reddish part. That is model building part. What is training part? Yeah, training comes under this only. So this is the training part where we just give some data to our model. Okay, now you just get learn from this data and return and for the unseen data you have to perform the analysis, whatever the prediction you have to do. Then deploying means connecting it to the, see over here, this is the deploying part. For example, we just launch our HCF website, but in case let's say we want to launch a website where anyone can put some of the basic thing related to their heart disease, and that online, that on the website only they are getting the result okay, you are having this issue or not. For example, we have developed a website which can tell anyone's having what we say the common flu or common cold something. So what are your symptoms? You're just putting some symptoms into that website, and as soon as they put the data into the website, this is being fetched by the model, that is pickle file, that will be sent to pickle file, that model. And once the model runs the test like prediction test, and it will predict yes, you have a common cold or not. So yes or no, for example classification we have, so yes and no. In that case it will give the result back to the website. That is nothing but your deployment part, deploying machine learning models. Any doubt till here? Anyone, any kind of doubt? Somebody put some, okay, great. See, this is how we can continue our part, that building and training, how it works. See, we have initial data set somewhere and we perform EDA, that is exploratory data analysis over there. PC and SOM, leave it for right now. Okay, if you want you can learn, it's right now not required, PC and SOM. Initial data set, when we have initial data set, we'll do some pre-processing, like removing the NaN values, that is not a number values, or like क्या कहते हैं उसको, skewing it, like if it is a distributed from, for example, the initial value is 100, and for somebody else data you have that value around 1 lakh. So that is too much of the difference in between. So we'll do the scaling part. Okay, min max scaler and multiple. I'll teach you right now in the uh, next 10 minutes. Then we do the data split again yesterday part, 80%, 20%, 80% for the training. That model will get this data to get trained on by knowing okay, what is the outcome, what is the true case, what is the false case. But over there, the true and false case will be hidden, and it will be given to the model to check okay, is it predicting true or wrong. So that is the predicting value. That is the training part overcomes here when we split the data and we give it to this. Okay, after that we do the model evaluation part. Again, classification we use calculation, accuracy, sensitivity, whatever written over. REMSC is nothing but root mean square estimation or mean square estimation. R square is another method for the regression part. Right, this is the basic thing. Don't need to get frustrated right now. We'll just go one by one. And then comes to the deployment part. What is the deployment part? It's nothing but we have the training code, that machine learning training code, label data. We put in the model building, means what we have created a model, no machine learning model that will be predicting. Then we add with the web app or something application or your internet something website. So with this and that model, we will be joined together to deploy on the server side. That is called deployment. And again, once it is live, you can send it to someone else who can enjoy that service. You can send it to somewhere and you can sell it also. That is production, right? Like Google Gemini is working or ChatGPT is working. How it is working? It is having a model. It gives you an interface. You both are interacting together and deploying it and costing the user like $20 a month or $80 a month. So that is in the production. And there was a feedback, no? Okay, what is the? Have you seen? There is a written, no? Your data will be used to train the model for the future. So that is the again feedback system. How the current world is revolving, and according based on that thing, our model will get trained on the recent world data. Any doubt till here, guys? Any kind of? Okay. If you have any doubt, just raise your hand and tell me the point. Okay, brother, I am having doubt in this model building or somewhere. I'll do that part again. Okay, this is my main diagram which I used in the notes also. So you'll see it again in the notes section. And today I'll share this PPT which is half made only, but okay. Then yeah, okay, we'll start. In machine learning pipeline means we have a machine learning model. Now we need actually, I'll teach you on this. This is my favorite, not this. This one is my what is the name? ML pipeline. Okay. So what happened in this? No? ML pipeline. What is the basic need of ML pipeline? Just one thing. Ki once you solve any problem, and you via machine learning models. Like I solved a problem for heart disease prediction. Let's say heart disease prediction. I solved a problem using machine learning model. Now I want to sell it to the hospitals. Okay, hospitals can use to check for the patients. Okay, does they have heart disease or not? This will increase their performance. This will increase their accuracy also. More patient in a less time. So that will help hospital. So I thought of okay, I'll deploy it. See, mark my words. And again, you should have a notebook with you. Notebook. Whatever I am telling or whatever you are watching, somewhere, anything if you find important, just put it as it is in your notebook. And you can add extra stuff also. Okay. Yeah. So I want to deploy my machine learning model into the hospitals. At that time, what I have to do, okay, I have machine learning model, but running at my local host or my local machine. Then I want to deploy it. So deploy means I want a website like we have the hcf.org.in, right? Somewhere where they can go and they can put the values into it and they get access to my model. Which model? Which I have developed for the heart disease prediction. So that is known as deployment part, and this is a production also. You can call it as production also. Okay, now it is accessible by public, and once it is public, you can just there. For example, a person name. I'll pick somebody. Pragna, let's say. Pragna. Pragna visits to our website and she found okay, in this heart disease section I'll put my data. So say she opened the web page, she filled some of the data over there. And what is feedback? I'm teaching you right now feedback. So what will happen? Okay, this data will go to our model, that machine learning model. It will check does she have heart disease or yes or no. So let's say it came out no, she don't have any heart disease. So it will go back to the website and it will show no, you don't have any kind of heart disease. But what is feedback over here? This data, the data what she has just put in our website, will be used to train our machine learning model for the future. So it is kind of self-learning, not self-learning, a loop of learning. The data, the current or real world data in the real time. Who is texting this one? Loop of in real time. Any doubt till here, guys? Any kind of doubt? Any kind of doubt, guys? Any small, big? I'll just open this. I'll open it. If you have any kind of doubt, you can raise your hand. Okay, should I proceed further? A thumbs up for yes. Thumbs up for yes. Okay. Okay. What is next? This is the basic why we need pipeline, the basic concept of the pipeline. Over here, our pipeline concepts, questions are what ends, or like what is pipeline ends over here. What is ML pipeline ends over here. Now the comes to what are the processes involved in the machine learning pipeline. So there are multiple processes which I have just kept into that PPT. The first and foremost is the data collection part. See, we need if you want to train machine learning model. So what do you want to train it on? You need data. Those who have attended my first workshop have seen like this hand was there with the red of the heart. I kept near to the data. That's what I was trying to say at that time. If you want machine learning model to deploy or develop, you just need the basic thing, that is the data. So how you can get the data? There are multiple ways. First way is either you start collecting that private and public, you can go two way, private and public. Private means, for example, you want to collect your data. As like few months back, me and my friend were wandering here and there in the multiple classes to collect some data on a Google form, right? Many of you have seen us, might have seen us. So what we were doing collecting data based on some student depression, right? That is my private work. Okay, for example, the better example will be DSU data, like not DSU, college data. See, if we got see, that's what I have to avoid. Whenever you got, say, if anybody wants to become entrepreneur or something, one key rule you should always remember: you should not quote any company or any private limited or anything in your. If you are a company, if you are a company, you should not quote any other company. Else they will say like multiple issues will come. They can raise a complaint that they are shaming us or like blaming us or doing some bad about us. So that's why you should avoid. I'm teaching because I also learned this. Okay, in future if you guys start a startup, so at that time avoid this. So let's say there is an institution, private institution or any institution which offers courses like BCA, MCA, or any kind of technical stuffs, or you can take a example of any school also. School. In that, what happens? No, कि they have data of each and every student, right? Okay, their name, their parents' phone number, their address, and multiple things. So that is the data. Okay, you first have to collect raw data. This is known as raw data. And then we go for the cleaning of the data. What means cleaning of the data? Okay, for my machine learning model, might be name is not important, or that phone number is not important, or admission number is not important. So I have to remove something. I have to deal with and multiple things. Or somebody might have written their age as I gave example already also, age as 18, instead of writing like this. So that is also I have to do. That is another part. That is your all comes under feature engineering and data analysis part. Okay, so what I was telling right now. Okay, these are the data. The main part is the data. You can get it from a private, but mostly the institutes don't disclose into the public. Like you can't access until unless you are an employee. So those who are the employee, like admission department, they can access the data. Those who are in the fees department, they can access. But let it be a student or any out department person, you can't access it. You don't have any access to that. So you need a proper authorization, AUTHOR authorization, right? So yeah, you need a proper authorization to get the private data. It can be any company also. Let's say you are working in Google and you are working on some machine learning project. So you are not allowed to share the data what you have in the public. That is the private data. And what is the public data? Public data means कि, for example, there are multiple government websites. I'll put test means one topic ends over here. Multiple government websites where you can get the data. For example, NIH, National Institute of Health, NIH. Something is there, NIC. So if that is the portal or .gov portals are there, they what they do, no, they gave some data to they make some data available to the public. Why? For the research purpose. For example, let's say there is a Indian government website, which gives data for the agriculture, like related to the land, type of land. Okay, is it like cotton-based land, or there are multiple, loamy soil or something, black soil, red soil, multiple soils are there. Those who have read in 9th, 10th class in geography. So that agriculture type of land, okay, or type of soil, you can see soil, type of soil, then type of land. Is it public land, government land, or a private sector land? Type of land. Then area. So if you have this much, or like one more feature or one more क्या कहते हैं, attribute, that is कि how much production was there, how much production happened that day, that year, sorry. So if you have this data, no, government make this available public because researchers like me and you, researchers like me and you can come up with some novel ideas, right? Okay, we can have, let's say you train a machine learning model, or you created one IoT based device or something agriculture related, you came up and to solve this problem. So this is the main motive of making the data public. So this is mostly done by the public data is mostly done by the government website. Like for the America also, American government also releases multiple data. Like you will get n number of data. WHO, World Health Organization. So they give data mostly for free, and they are available open source. So there are two types of the data, private and public. Both are done. Any doubt till here? Should I proceed? Okay. So basic in one line, it is a process of gathering the data from multiple sources for our क्या कह सकते हैं, for our क्या कहते हैं, aim or target to develop a machine learning model. That is data collection. So one of the major part is done. We'll see the next part. I think so that is EDA or feature engineering something. Yeah, data collection, then feature engineering. That comes, EDA also comes under feature engineering, or vice versa, you can say. So what happens, no? Not vice versa. EDA comes under feature engineering. What I was trying to say. Let's talk about feature engineering, then we will talk about EDA, right? Am I going fast? If you guys think like if I'm going fast, just let me know right now, because if I slow down, I will teach each and every basic stuff. So most of the people will start doing yawning and all. Okay. And yesterday in the class at the end, no, I saw one person who just kept joined the class and kept the screen on and went somewhere else. So at the end, I found somebody. Okay, no issues. We'll continue. That is feature engineering. Okay. And what does this feature engineering means? First of all, what is feature means? Features means nothing but your column, attribute, the thing which is defining your data. For example, for a car, let's say this is a brand new model car. Okay, with some steering wheel over here, just 5 crores only. So this brand new car have multiple features over here. Let's say one high tech gun. How gun looks like? High tech gun to shoot your enemy. One tank or something, nozzle of the tank. Okay. So yeah, this car costs you around 5 crore. That is okay. But what are the features? First feature, for a real time I'm telling you, the feature will be it has a gun. Second feature will be it is a mixture of tank. Third feature will be it has 4 wheels. Fifth, it's not okay. We'll make it autopilot also. Autopilot. The fourth feature will be autopilot. Fifth feature will be anything blah blah blue in color. Let's say blue in color. The point of telling feature means okay, this is the real world part. We talked about real world any product, but in the our machine learning feature will come for the data. We gathered the data. Let's say we had a survey, okay, like for the student depression only, and in that I asked for multiple things. For example, name. No, I didn't ask for the name. Let's say I asked for the age, gender, academic stress, CGPA, and academic stress मतलब 0 for low, 1 for slightly, 2 for more, and 3 for like extremely high pressure, and financially freedom or something. Not financial freedom, financial problems. Okay, so that is also on a scale 0 for low, 1 for small, little, 2 for high, 3 for extreme. So the data will look like this. Dash, 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 dash. Same thing. Now what's the feature over here? Now feature of our data set will be, anyone who wants to tell? Anybody? What will be the feature of this data set? Guys, you should have courage to speak. Anyone can unmute and speak. Age, gender. Okay. The feature will be all the column name: age, gender, academic stress, CGPA, and financially problems. So this all will be the feature: gender, academic stress, CGPA, and financially problems. Okay, so these are the feature. Now what does matter for me? For example, if I put one more thing, okay, do you like chips? One more question extra. Chips. Do you like chips? So that is not a valid feature for my main aim or goal which I'm doing. The main goal is to predict the academic stress, right? But over here, what I found that the chips part is not playing a crucial role. Why? Because that is common sense. First of all, it comes from common sense. Second, you can plot known as heat plot, heat map. That gives you the correlation. Here one word comes correlation. I'll teach you this also. Correlation, heat map, everything we will cover. That tells okay, how much one thing is dependent upon another thing. For example, how much academic stress is dependent upon chips consumption. But no, like 0.1 something or 0.01 means ki academic stress, if somebody have academic stress higher, that doesn't depends upon their chips consumption. Like if it can be zero also, it can be negative infinite, it can be positive infinite, means they can consume n number. If they don't also consume something or they sell it or something, that doesn't matter upon their academic stress. That's the main point, right? So this is known as feature reduction. You can remove this feature. All right, then feature engineering of the data set हो गया. Any doubt till here? What does a feature means? Do you guys got the clear view of what is a feature? Should I proceed now? Okay, there are multiple websites also for the data part. I forgot to tell. That is, you can get in the notes also. What the notes what I have prepared, you can find it over there. You can get. The famous one is Kaggle. Kaggle data. Over there are multiple data which are free to use, which you can use to deploy or train your model. All right. Now feature and engineering, what does over means? Okay, these are the features, but what engineering I can do? Engineering means okay, I can merge both of them, merge multiple feature, multiple to get one, or I should remove some feature. This is the one way. This is remove feature, or what I can do? I can change the way they are formatted. Format change. I'll teach, wait for a minute, I'll teach this also, format change. Okay, there are multiple things comes under for this feature engineering. For example, the format change. I will go number line by line. Alright, so the first thing will come for the feature engineering part is the types of features. Alright. Before, if you want to deal with the feature, you should know how many types of features are there. There are actually 4 types, but you can, for us, we will describe into a 3 type only. If you want, you can distribute the last one into 2 more. But mostly we will deal with this only, this 2. The first one is your categorical feature. And over there comes time series. This will come textual, like some data or some messages what you gave, and another come for the numerical feature. Okay, what this categorical means? Okay, it can be like A, B, C, D or something. A, B, some category based. C, D. Numerical can be 1, 1.2, 3.5, something. Time series means 5th of August, 8th of July, or blah blah blah. That is time series. Textual means, hi, my name is Amit. You got the point. Categorical means where we just define the category. It can be cat, dog. It is not a. It is a type of text, but it's not it's not a sentence. It's just a word which defines a category. It can be car, cooler, AC cooler, fan, AC, or anything. That is a categorical feature, which you can name as an object. Numerical means anything. It can be 0.5, 0, e to the power minus 25. That is a value. But yeah, time series, you got the point. 2025. It can be timestamp also. Right now the timing is 16:40. So this is also a time series. Textual में और क्या आ सकता है? 4 number will come in textual. So mostly we deal with these features, categorical features, numerical features, and textual features. Textual features we mostly deal with while developing LLMs. Time series we use for the real world problems, and these two are too much common such that every dataset must have this. This is two basic thing. Okay. Any doubt till here in the types of features? Anyone? Shall I proceed now? Okay. And here are we do one more thing. Categorical features. Categorical features are divided into two more. That is binary and non-binary, or multi-class you can say. Binary, non-binary, or multi-class. Multi-class. What happens in binary? Binary means yes and no. For example, yes, no. Or where you can divide into two, like infected patient, not infected patient, or anything. It's a car, not a car. Similarly, for this you can go for cat, dog, buffalo, and number of things. Yes, no will be like 0, 1 you can count. That is also a categorical feature. If you do in two class, what is non-binary? Non-binary comes for non-binary means not a binary. Binary means two. So not more, 2 means it can be 3, it can be 4, it can be 5. For example, your CGPA. CGPA is not pass and fail. CGPA is about, okay, it can be 8.5, it can be 6.3, but that is a continuous value. But over there you can say like, okay, we did one thing. Those who are getting 0 to 4, that will be considered as good, and like average. No, 0 to 4 should be fail. 0 to 4 should be fail. 4 to 6 should be average. 6 to 9 good, and 9 to 10 outstanding. So here what I did, I divided my data set into 4 different classes, right? First class is fail, 0 to 4. Second class is 4 to 6. Third class is 6 to 9. And fourth class is 9 to 10. This is known as multi-class. Right now it will sounds okay, yeah, basics things. But once you are developing machine learning model, no, the terms will be not like, okay, how many classes does it have? Is it a multi-class or binary class? At that time we'll feel. So this is the multi-class, yeah, or non-binary. Any doubt till here? Should I proceed now? Okay. Then there are multiple feature engineering techniques. What? See, the main key pillar is two. That is feature engineering and EDA, exploratory data analysis. For that EDA, you need 3 things. That is NumPy, Pandas, Matplotlib. And for feature engineering, what you need? You need the basic understanding of the features, right? So these are the 2 key pillars you should always take your mind whenever you are going to deal with the data cleaning part or data pre-processing part. Okay, because not every time you are getting the exactly structured data. What we say exactly meaningful data or quality data. To make it a quality data, what you have to do, you have to perform these of the techniques, or multiple techniques are more there, but they comes under this category only, EDA and feature engineering, to make raw data into quality data. And why we need quality data? To train our machine learning model. right? Okay, now we'll go to the next part. Okay, we got the feature engineering. Okay, what is the meaning I got? How many types are there? Got, but what are the techniques to do this part, feature engineering? So this is a good question. So we'll go now with the techniques of the machine learning part. Oh, sorry, feature engineering. Techniques, sorry, techniques we perform in feature engineering, right? There are multiple techniques. First of all, it depends upon your data. There is no क्या कहते हैं fixed rule. There is no fixed rule that all the time. There is no fixed rule. Sorry, no fixed rule that all the time you have to implement them. Implement all of them. It depends upon. So this is the important part. Might many of you think why I should use this technique over here? Why should not I do? What is the use case? So that's what I'm telling. There is no fixed rule of doing the feature engineering part, as it depends upon your data, as it depends totally T-O-T-A-L-L-Y, totally upon your data set, right? So what are the techniques involved in the feature engineering? First is the basic most is handling missing values. Okay, I'll go through one more thing. I'll show you some basic stuffs. Let's say we'll go to one of the website that is known as Kaggle. Kaggle is nothing but your open source where you can download any data. Okay, you can basically click on sign in with Google. You can easily sign in. Next, username is already taken. I'll put something. Agree. Okay, here my account got created for the Kaggle, right? Now what I want to say, I want to do, let's say, for some missing data for my EDA part. Exercise. See, I got one thing: exercise, data types, and missing values. Okay. You can go below to that also. For example, okay, I'll remove this. Okay, nice. Is there any data set? Input data. Okay, this is one of the data. We'll see the data now. 1.18 million US wildfire. Why I'm showing you this? I'll tell now. Just wait, hold for a second. See, total columns. It's not any CSV. What is this? Some other data set. Okay, from next time I'll download the data set. This is chess game data set. I'll open it up. I want to show something. What is actually missing values mean? Why am I coming back over here? Say game.csv I got. See over here. Is it visible to you guys? Is this dataset visible? Okay, this is how we download a dataset. I'll see, this is the basic thing, because right now we just need we just need some data. For that I did. See, whatever the thing written over here are known as features. If somebody asks you how many features does this data set have, so that is P, that is 17. P stands for 17. 16. Yes. And this is known as instances. For example, this. All the data for the multiple rows, this all stands for the instances. So if I keep on going, this is the bar. I have to scroll down, I have to check. That is 20,000 instances this dataset have, or 20,000 rows. All right. And feature stands for the upper this one, or the number of columns, that was around 16. All right. Now what we want to do, we will do something like we will find some missing values over here. Let's say if we can find something. No, right now missing value stands for example, I'll do something. Okay, 3 only. Okay, we'll do replace with nothing. Okay, as you can see right now, there are some null values, right? These spaces are empty right now. That means these blocks are empty. Means this is a null value. Null means nothing is there, no value, right? So what we do, either we can do one thing. See, we'll do one thing. One by one, we'll do white, or black, whatever we have changed with. Black again. We'll go with this also black. This is one way, but that is not an optimal way. What you can do, there are multiple techniques again. I'll teach them, but this is the basic thing why I opened the dataset was to tell you what is a null value and how you can detect. I'll teach now this on this. Okay, handling missing values you got. Now how you can handle. Here handling are multiple depending upon your data. See, if there are more than 10% of missing values in your data for a particular column, drop that column. Right? Reason being, I'll tell you. If you because if you somebody can ask me, no, okay, bro, why we have to drop? What does this drop means? See, drop means this. I'll click on this. I'll delete. This means drop. Drop means removing that column from a data frame. This is known as data frame. The whole your data is known as data frame. Removing any particular column from a data set is known as dropping that column. Drop means no, you tell I'll drop you, so you take your friend and you drop at their home. That is means drop. Same thing. Removing something from somewhere. Your friend from your house. That is also known as dropping your friend. So why we need to handle this missing values? Definitely, if you have a data, okay, which have multiple missing values, right? This is missing, a multiple, more than 10%, and you feed it to the machine learning model. So what will happen to this now? It will predict false. It will start doing false prediction. Why so? Because the data is not available for that particular reason. For example, there is not only one column, right? There can be multiple rows, multiple columns also. Now the data part is okay, this is the missing and multiple values are missing over there. Multiple, like more than 10%. Let's say 50% of the values are missing. So what you should do, you should drop. Reason being, machine learning model will think like nothing I have to predict, so it will misguide. It will do misguide the उसे क्या कहते हैं, that equation. Or once your equation is misguided or once it is unbalanced, then it will give the false prediction for the real world problem. That's why we either drop or either we fill. So this is the case ki if it is greater than 10%. So what is the else statement for this? Else we will replace the missing value. Replace the missing value. How we can replace? Sorry for this, but everyone got this point. Is how handling missing values. The basic what I taught right now. Any doubt in this? Anyone? Any kind of doubt? Are you guys getting the point? Or you guys just get, okay, let him teach because we paid. Okay, let's continue further. Why we replace missing values? Because each and every time, let's say that is 10%. What we in case we got 9%. So in that case, again depends, if you want to drop, you can drop. It's not a क्या कहते हैं, fixed rule that in 10% only you should drop. You can, if you want, you can drop. But depends upon the efficiency and the actual neediness of your model. CNC and neediness, जो भी कहते हैं, requirement, you can say requirement of model. For example, let's say you have a data set. Okay. In that data set, there was a column named as blood pressure. The data frame is for heart disease. Okay. And you find more than 10% of the data are not available, like 9%. So what you thought, okay, brother told me to drop the column. I'll drop the column from the data set and then I will feed this model to machine learning. Feed this data to the machine learning model. Bro, in that case, you are making the blunder. You are removing the main factor, that is BP, for a heart patient, right? So it depends upon data to data, column to column. If in this case, if you have only 9%, remove only that 9%. Like for the rows which have missing values, let's say for this row, this was the missing data in the blood pressure. This was missing. So I removed this row. I dropped this row. I again dropped this row. Rather than dropping the whole column, I just drop this row. Because if I remove this whole column, my machine learning model is the waste, will become waste. Because the main key feature I am removing. You got the point, how you have to deal with the missing values. In each and different cases, that depends upon the data. I'm telling you again and again, there is no fixed rule. This is, you have to apply all the time. It depends upon data, the correlation, if one feature is dependent upon another or not, or but yeah, that if the both are dependent upon if you should drop or not that particular row or column, right? Any doubt till here? Okay. One more thing I will tell. Let's say I have 25k instances. 25k means 25,000. Instances means rows. Rows and instances are same. So in 25,000 rows, what I felt like, okay, for this, my 5% of the data are missing for a particular column. What I'll do, okay, okay, let's say this was 125 something rows, right? What you will do at that time, if you want to drop this 5%, no, that will make very less change. It will become around 120 something, 120k data. That is still fine. In that you can drop it. So it depends upon your data size as well. Because if you are gonna getting deal with each and every row for that data, what should I do, what should I not? So if you want to remove that 5%, definitely you can go for removing. Because if you are losing 5,000 data, that is still very less as compared to 1,20,000 data, right? Divided by 5 to 24. That is still 1:24 ratio is there. So that is actually nothing. Are you getting my point? You can remove that 5%. That won't hamper. It won't hamper your what result. It won't hamper. 95% it won't hamper. It won't hamper your results. So in that case, you should drop. If you want. Else, if you want to know, I'll replace with the mean value. I'll put the mean value of the column to that. It's still fine, but that is slightly difference will come. Slightly difference will come in what? In your accuracy. Because that is not the actual data. That is the mean data. Here might be कि gender is female, and here rest of the missing values were, or most of the values were male, right? And for the male, some values were present in this column. What you did, you just mean of this, which depends upon male, and you swap to the value which depends upon the female. That is not correct, right? So this is a wrong value. Like the correlation will become wrong whenever you try to plot the gender versus this column. No, this, let's say M column. So there will be an issue. That's why you should check everything. And by removing this, if it is not hampering your data, like this in this case, you should drop. Any doubt till here? Any kind of doubt? I'm telling you again and again, that depends upon your data set. And to train a machine learning model, you should have bare minimum 700, I think so, 700 instances. Like my personal experience is around 400, it will work, but it's not sufficient. 700 instances is the safe side. It's the safe side. Whenever you are choosing any data set for your project, you should always check for the 700 instances, like minimum. For in case that data set is rare and you got around 400, that is also fine only. But in somebody say, here 250, how about 250? I'll say no. That model will become overfit or underfit. That is overfit, not underfit, overfit. Right. So bare minimum 700. There comes one concept of overfit and underfit. I'll teach later before I complete this part. Handling missing values. So there are multiple ways to handle missing values. One of them is replacing, one of them is dropping. So either you can delete it, either you can impute it. And how you can do imputation? Imputation is nothing but replacing that null values. I'll write over here, replacing null values. How you are gonna do this? The basic thing, there are 3 ways. Sorry. First is mean, another one is mode, and third one is, anyone? Yeah, who told this? Good boy. Guys, clap for that guy, guys. He gave the answer for the toughest question alive. Okay. Mean, median, mode. See, these are the 3 basic techniques which we use to replace the null values. Okay. And for more clarity, in the last internship, I have on the YouTube only, you can go and check for a last EDA part. Over there, everything is explained in depth. I'm not going to teach everything, why every time you should use mean, mode, in what case, median in what case. In that, you can go and check. Right now, main focus is machine learning algorithms. If we go stuck over here only, in EDA, that is again a lone topic which can take 30 days to go. EDA and FE. Okay, so mean, median, mode, there are 3 ways. Mean means nothing but adding something divided by this value, like sum of total number of elements, and this is the sum of elements, sum of all elements. It will give you some value, and replacing all the null values, let's say this is null values, NULL. So replacing this value with some mean. Okay, median again also. But why we use mode? Mode is used for categorical features. Categorical features I told you, A, B, C, D, yes, no, somewhere I told. Yeah, this one, good, average, fair. In that case, you should use this one, mode. Any doubt till here, guys? Any kind of doubt? See, if you don't learn this and if you think I can become machine learning expert, so no, not a chance. You should be having good grasp on feature engineering and EDA. Perform EDA and feature engineering for check for multiple data sets, get it download from Kaggle and all. Keep on practicing. And then comes for the outlier parts. What is outlier? Outlier like Among Us. Many of you have, I gave this in, AI works. Among Us. There was a person, there was a single person who was, क्या कहते हैं उसको, something. And here is whole team, and one person is that, what we say, who play Among Us. There is one person that stands out all the time. Imposter. Imposter. One will be the imposter, and rest of them will be the crew member or something, whatever. Members, let's say. Members. So who is the imposter? This guy, one guy. Similarly, in our data set, what will happen now? In our data set, there will be some data. For example, we have let's say I am collecting data for student depression. Let's say example, I'm collecting data for a student depression. Over there, I circulated the Google form. Okay. In that, some of the notorious students, what they have filled, their age as 530. Let's say someone filled 890 or 1024 or something like this, or minus 56. Okay, so these are the values which is not possible. Like that is not feasible as per this parameter. Are you getting my point? These are known as outliers. There is another name for this known as anomalies. What does this mean? Which doesn't belong to a particular group. That means that doesn't belong to rest of the what we can say data points. For example, in that Google form somewhere like okay, age were 18, 19, 23, okay, still acceptable, 25, acceptable, might be PhD student. But over here, if somebody writes 98, it is an outlier. These are not an outlier. There is a chance that this can be an outlier, but if 98 is present, then this is not an outlier. Or we can't say like this, but yeah, this is not an outlier. Because it is near to the rest of the value. How you can define this is an outlier or not? You have to check that value compared to the rest of the values. And for this, we do a technique known as box plot. There is IQR technique, interquartile range. Then one more was there. I'm forgetting it. IQR you can use, box plot you can use. Okay. Yeah, let's continue. So 98 or somebody will write 108 years. For a student data, it can't be like this, right? But here you got an anomalies. I'll mark it as right. These are the anomalies or outliers, right? Fine. Okay. Yeah, we found something. But once you go for some other, let's say another domain, we'll go for what we say, sugar level. Over there, let's say we have a data which states sugar level of 5 patients which look like this: 100, 120, 150, 400, 490, so or 370. See, let's say this 100, 120, 150 are in normal range. But 400, 490, 370 are not a normal range of a sugar, right? So it will become outlier for your data, right? Any doubt till here? Anyone, any kind of doubt? If no, just put thumbs up. Okay. Now for outlier treatment, what we do, it depends upon data again. Everything depends upon data. So if it is a student data and we are talking about age, we have to remove this data, or we can replace it. We can replace it with mean or something, but that is also not a good way. So either first treatment is either you can imputate it, replace it with some data. Those are outlier, because if you want to see, this is not necessary. In that Google form there is only one column. There will be another gender also. There will be academic stress, financial stress, or multiple parameters. But you want rest of the data, and you don't want to lose them. So what you will do? You will impute it with the mean. Let's say mean is 25. You will replace it with the mean, the outliers. Why we need to treat outliers? The question might came. Okay, brother, I got what are outliers, but why do we need to treat outliers? Why do we need to treat outliers? First question, and the answer for this is what happens now? Okay, in the last class only I told you there are algorithms which works on equations, and in that equation there are two parameters known as. Do you guys need right now? Okay, weight and biases. Don't get involved into this right now. Just leave it. These are the two parameters every model needs to create their function. Yesterday I showed something, this gives something k value, right? Let's say a plus b gives some k values. This is the equation, a general equation, right? Similarly, models use two parameters known as weight and biases. Weight and biases, which they define by training on the data. By training on the data. Okay, what for example, let's say heart data. In that, what will happen? Okay, every feature, let's say age, gender, BP, cholesterol, heart attack, ECG, sleep disorder, everything will come. And what they will do, they will gather all the information. Like we have the information in data, right? That is CSV file or some file. In file, we will have a data. CSV stands for comma separated value. Now we have the data in Excel file, XLSX, Excel file, and we want to train it on a machine learning model. So once you are giving this data, the all data of 1000 patients to the machine learning model, it will find a pattern. What it will find? It will find a pattern into the data, in a data, based on the features, based on feature correlations and anything you can say, features correlation. Based on features correlation. Okay, so ये एक pattern ढूंढता है. It will find a pattern and that pattern will be given by a equation. Right? The equation what I am talking about is this equation. By using this equation, it gives a pattern. Right? Okay, sir. How? Let's visualize it. How a machine learning model gives this and why outliers are necessary to remove, or how we can treat. For example, this is an equation y is equal to mx plus c, right? A straight line equation. It over here, anyone who can come and tell me what is m and c? Anybody? Anybody who wants to tell what is the m and c over here in this equation? C is for? Okay. Whatever, but yeah, correct. Intercept on y-axis. Now, there we have to find what is normal way how a machine learning works. Okay, we have to find a pattern. This is the pattern. Okay, on what? On a data set. And how is the data set? This is our data set where values are distributed like this, right? And you want to plot create a equation which gives the best separation, best result onto this data set. Let's say this is data set, I'll write data set, right? So what we did, that machine learning model, we gave this whole data to our machine learning model, and his work is to find a proper best fit line to separate. Let's say this is the best fit line. I'll make the data more good so that you can easily understand. Let's make it proper now. Let's make this proper. Here it comes the concept of this line and all. ML algorithms. Okay. Let's say this is the line and the data set what we have. If you have raised your hand, just let me know, because I can't see. If you have any doubt, you can raise your hand and you can speak, because right now my focus is on screen. So okay, let's say this is our data. Something yes, no. Okay, that person is having some data, like some disease or not. That cross means yes, and this O means no. that disease is present or not. So what will happen, no, if we give this data set, this whole entire data set to our machine learning algorithms, okay, such as linear regression, not regression right now because we are doing classification. So any model, right now you just consider model, don't get confused in classification or regression. Okay, we give what this model have to do, it has to separate those and it has to learn the data. Okay, on what parameters, let's say this is age and this is something, heart attack or something. Heart attack. This is how they are correlated. That means yes, इस age पे, इस condition पे heart attack आया था और something is there, like not heart attack. Let's say this is उसे क्या कहते हैं, blood glucose, you can say blood glucose level or sugar level. Sugar. Okay, what will happen over here, कि the machine will try to check and find a pattern कि okay, these are one kind of data, this is another kind of data, how can I make them separate? So it will find, okay, yeah, I see there is a linearly separable line between both of them. So what it will do, it will try to plot the best line which separates most of them. It might be, there might be a case which can come like this, which is neither your line can go over here, neither below to it. So this is okay, then you're in that case your accuracy will be 99. And if let's say, yeah, I'll just put the line right now, just learn the basic concept. As soon we dive in, we'll cover the rest of the part. So this is yes and no, and this is how a machine learning tries to create a model, like an equation of the line. Over here there is a line of equation, right, for y is equal to mx plus c, and based on this it created an equation based on what, based on the data set given on two factor age and blood sugar. And this is yes, heart disease was present, this is no, heart disease not present, or heart attack was not there. Okay, so it created a line. So what will happen now, there will be a particular equation. So for, let's say there is a new trial value, okay, what will happen for the blood sugar level this and age this. So it will go like this, and it will it will try to check for the x and y intercept. Over there it will find, okay, this is the value, whatever the regression, if we are putting, regression will give this is the how much percent chances, 0.5 or 0.8. Or if this line points comes left to this, yeah, there is a high chance. If it comes below to this is a no chance. Any doubt till here? Or a new data set will come based on the equation. Okay, is it putting that value, what we are getting from the equation, putting on unseen data, is it getting right side of the line or is it getting left side of the line? If it is on the left side, yes. If it is on the right side, no. Any doubt till here, guys? Any kind of? See, don't try to learn everything in a first class. I'm just giving you the whatever I can explain the best way about the machine learning I'm doing. If you have any doubt, or somewhere I got like messed up for you, or you think, yeah, brother messed up, so just let me know. I'll teach that part again. Okay, we were there why we need outlier. So what happens now for the outlier in the same data? Now there will be an outlier for this, or I'll draw one more diagram. You'll come to know easily. Now if you try to put a line which separates both of them, you have to do like this, right? Because on the left side of a line it is yes or no, whatever one sign, that is 0, and this side it's cross, right? So to deal with this problem we need to remove the outlier. How can it be a outlier? See, for this range, this is the basic, like this is in a one range, but these two are far away from both of them, right? Some distance away they are present, so they become outlier based on this class. Let this be age is 18, 20, 30, 35, 40, 45, 50, 52. This is around 400 something, this is 500 something, so this is become outlier for this, right? You got my point. So that's why we have to remove this outlier, so that our model should not get overfit or underfit. Any doubt till here? These are the outlier in this case. These two are the outlier. Okay. And yes, in multiple cases, for example, for the sugar level, you have to keep the outlier because these are the clinical result that are clinical result, right? Which is playing initial or like playing crucial role while training the machine learning model, training ML model. Because 400 is achievable, 490 is achievable, 370 is also achievable, but 100, 120 and 150, based on this, these are the outliers. Outlier is nothing but a person. I told you, in Among Us, there is one person who is imposter and the rest of them are normal people. Same way. And there can be multiple imposters also if you are playing multiple game. Like, I don't know how to change, but yeah. The same way, there can be multiple outliers. You have to deal with these outliers. Okay. Else your model will become overfit. For this also, you have to do outlier analysis. Right? Any doubt till here, guys? Any kind of doubt? Do you guys need break for 1-2 minutes or something? If you have a doubt, you can speak now. Should I continue? Are you guys able to digest this type of things? I'll share the notes. In that, I only created that note, so everything is typed. And if you find any kind of problem, just let me know. You can comment out on the YouTube or anywhere you just reach. Just put that question. So, in some way, we have to keep the outliers in this case, and some way we have to remove the outliers, or you can replace with mean or something, right? So you can do replace. You can transform. What is the one thing that is transform? Okay. I'll take the example of this only, 100, 120, 150, that glucose level का example ले रहा हूँ. 150, 490, 500, 530, 1200. That is 1200 is not possible actually. But yeah, or okay, we'll take this also. I'll take one more example. At that time I'll explain. One more example I'll put right now, salary. Else I'll forget it. Salary. So in this concept, what will happen? No, the transformation. I'm teaching how to do transformation of outlier. Transformation. In this, I'll become little bit fast because it's already 1.5 hours over. So I have only half hour to complete the today's syllabus. So I'll be little bit fast. If you have doubt, just let me know. So transformation means okay, I'll see for right now what will be the outlier. Outlier, the most become outlier is 530. 490 is also outlier because rest of the data is. Rest means this should be more, no? You can ask, bhaiya, does not, okay, model will think like this is the basic part, this can become outlier. Yes, it can become outlier. So, but depends upon number of the data, what you have. If you have this type of data, 50 or 60, and this is only 3 and 4, so these are the outliers. And if vice versa, okay, if we have only this 3 or 4 types of data, 3 or 4 values, and for this we have 500 or 600 values, yes, this will become outlier. Okay, so outlier depends upon the data what you have in that column or data set. So transformation will become, okay, I'll take this as my minimum value, I'll take this as my maximum value. Okay, I'll transform it such that 100 will become 0 or 1, 0, let's say 0, this will become 1. There is this concepts come for the min-max scale. Those who know this concept, they can correlate. Like, we want to skew it, not skew, like you want to transform everything which was right now the data set is from 100 to 530, the same thing, same distribution, but from 0 to 1. How it will be done? Okay, divide 100 by 530. 100 by 530. How it will be? How much it will be? I'll open calculator. 100 divided by 530. It's 0.188. That is 0.188. And what is 530 by 530? That is 1. This will become 1. And why I'm doing this? I'll tell you why. Why can't we keep bhaiya as it is? I'll tell you why. But before that, let's proceed with this knowledge first. Okay, now this become 1, 530 by 531. Now divide 500 by 530. Anyone if you can do, this will become 0.9 something. So now the data is 0.9. And if you do 490 by, open the calculator. 490 divided by 530. That is 92, 0.92. So this is 92, so this will be 95. So this is 95, this is 92. Now see the difference. This is 0.03 difference, right? Earlier the difference was around 490, this is 40. And if you do 150, do 150 by 530. That is 150 divided by 530. That is 0.28. So it will come over here, 0.28. Now the difference is 0.7 only between these two, right? Are you getting what I'm doing over here, or you want it in a better way? If you're guys getting what I'm doing, just put thumbs up. Everyone means everyone. Yeah, somebody raised their hand. If you raise your hand, that means doubt. If you put thumbs up, that means yeah, you got the concept. Okay. So this is how now the scale becomes 0.188, and now this becomes 1.0. This becomes 0.95. This is 0.92. This is something 0.28. See, now the difference is very less, right? The transition from one data to another data is very, very less. That's why we prefer this. Why? Again, question, why we did this? Why we took this approach? The reason for this, the reason is our computer or model. If you put data which are very vast in the number, for example, the initial point was our 100 and the final point was 530, the computer will become more biased toward the higher number, or let's say 100 or 10. If you have 10 also in your data set, which is the minimum point, if your data set vary from 10 to 530, so your computer or the model, what you're doing with, or the training you're doing on a computer, that will become more biased toward the higher value. Okay, for every case. That's why we just did scaling part. We just put the transformation between 0 to 1, such that now computer have only options between this, and computer doesn't find any differences between these decimal points. They have only their values. It doesn't give any precedency to value. Okay, this is 1 means high precedency, this is 0 means low precedency. No. When the scale is too big, like over here the difference is 520. So yeah, your computer will be more biased to this. Let it be in the less number, but there is a high possibility that this will also occur. That's how the model will think. Okay, 530 is one of the data point which I have in my data set, which was given me for the training purpose, right? In that, there is a high chance that I can predict 530 also. So this we want to avoid this kind of conflict inside the model training. That's why we do the scaling part. Okay, any doubt till here? Why we did the scaling for the outliers? Okay, let's continue further. Again, you can delete the outliers, you can remove it, you can replace with the minimum value, maximum value, mean value, whatever you want you can do. So this is the outlier part. Yeah. See, basic I'll tell you. Let's say you have a computer or the model, machine learning model which you are training, right? This is your computer. You gave the data like 10, 20, 30, 50 and dash till 1200 something. Now the data, 1200 will be 1100 also, it will be 1000 also somewhere, and dash. Like your data varies from 10 to 1200. In this case, now what will happen? Computer will computer has a one defect, you can say defect or precedency, like you can say क्या कहते हैं उसको, हाँ precedency only, okay, precedency, कि it will give more priority to large number. Let it be in very less number, let it be only one. For example, if your data set have this also, like 1, 10, 20, first, second, third, fourth, and fifth value is 60, and seventh value is 1200. So your model will think, no, there is a chance that I can go to 1200 also while predicting. See, you're training a model, right? So you definitely use this model to predict the values after the model training part, right? So while testing or prediction time, what will happen? No, okay, this model will be more biased. Like teachers are more biased to their favorite children, right? In the same way, computer will become more biased towards the higher value. Okay, this is the higher value, so it will try to predict like 1200 is one of the value. No, it will try to predict 1050 also. But most of the data are over here only. But due to this difference, no, this is the large number, it will give more priority. That makes the model overfit. Are you getting my point, Rajat? This is the main problem. That's why we did the scaling part. Okay, this is the huge difference. See, right now the difference is 10 to 1200, that is 1190. This is the difference between these 2 points. What I'll do, I'll reduce the difference. I'll keep only one. So how you can do? You just divide 10 by 1200. You'll get some values, that is 0.000 something, 1, 2. Or over here you will get 1200 divided by 1200. That will become 1. So now the data will range from 0 to 1. Why we choose this? Because over this case, computer don't have any क्या कहते हैं, priority. There is no much difference as the difference between 10 to 1200. And another thing, the computer treats 0 as same as of the 1. Both are same for it. Are you getting my point? The value, priority, I'm talking in the terms of priority. Okay, anyone else, any kind of doubt? See, I want to cover this whole topic. I don't know how I'll cover. Feature engineering still we are doing. For model training, basic I'll tell model training. Overfit, underfit. Evaluation we'll do while learning. Deployment is not in our course. Monitoring and maintenance. These 3 are not in our course. Because this is ML ops, machine learning operations. We have till here only. Evaluation, model training, and feature engineering. Okay. Anyone have any kind of doubt till here, whatever I spoke this much? Okay, give me 1 minute break, I want to drink water. Just a second. It's fine, I'm leaving my mic on. Okay guys, let's continue with the last part. Not last part, like feature engineering will cover, and if you guys permit, we'll go for 6:15, 6:20, because I have to cover Scikit-learn, that is Scikit-learn, or I have to wind it fast. So we'll see. Okay, now what's next? This is outlier daily. Anyone have doubt? Why do we treat outlier? Any kind of doubt? Okay, what is outlier? till now. Because once we will be trading model now, at that time I'll trade for a tell ki this is the outlier and that's why I'm removing it. So at that time you should not ask you what is outlier. Any doubt till now? Okay, we'll go now for the encoding part. By the way, what I'm teaching right now, no, in the AI works I took around for, like for the whole day, it was booked for the feature engineering and EDA. And I'm trying to cover both in 2 hours. Not EDA, but feature engineering. And for me, I took a lot of time to learn this encoding. So I can understand this is a little bit fast, but the point is you have to study and do mehnat. And encoding, yeah. What is encoding? See, computer can't understand what is red, what is yellow. Right. So that's why we have one language. What we call that language? Okay, to tell the computer that this is a red color. What is that language which use computer to understand the words or letters? Anyone? Zeros are ones. Zeros are ones are correct. Binary. Yeah, Surya told binary. Yeah, correct. Both are correct. Binary is the name of the language where we use 0 and 1. Similarly, this is for the क्या कहते हैं, computer. But for our machine learning models, once we want to tell the model कि okay, let's say we have a data over here. For example, कि I only collected the data from you guys. कि, okay, tell me your favorite color. So let's start one by one. Guys, start telling your favorite color. Anyone can put. Just tell. Yellow, blue, red. Blue, red, yes. Any one more color I want. Black. Okay, let's say these are the 4 colors which we want to tell the model, okay brother, now it's your time to learn this part. So how you gonna tell? So either you can give ki yellow is 1, blue is 2, 3, red is 3, black is 4. This is one of the way, right? I can do this because computer can't understand no yellow, blue, red and black. So I have to convert into the either numerical format, only numerical format, such that it can understand. And in the numerical also something 0, 1, 2, 3, 4. Yeah, it can understand. Our model can understand 1, 2, 3, 4. Again, it uses binary at the back end, but still it can understand these. But it can't understand yellow and red. Any string it can't understand. Our model, machine learning model. Right. So what we can do? Either we can do okay, I'll give yellow as 1, blue as 2, red as 3, black as 4. So if somebody else also have yellow as favorite color, so I'll give the 1 again. If let's say for me I have a favorite color, let's say black, so I'll give it 4. If let's say for me again I have the favorite color as red, so I'll put as 3. So what we found the similar trend ki we have mapped a pair with some particular values, right? This is called as label encoding. Label, LABEL, encoding, ENCODING. Any doubt till here what I did? I just specified a number for a pair, right? For a class I gave a number. That is known as label encoding. It is mostly used for when you have category. Like over here we have a category. So yeah, we gave it as a label encoding. Okay, any doubt till here? And it is mostly used when our data have a meaningful order. For example, good, better, best, outstanding. Okay. So good we gave 1, better we gave 2, best we gave 3, outstanding we gave 4. Okay. So in this way we use mostly for the data which have क्या कहते हैं इसको, मैंने अभी क्या बोला था, ordinal. This is ordinal data with have meaningful order. right? So this is one type of encoding. This technique is known as encoding, and one type of it, what I have done right now, is known as label encoding. Any doubt till here? No, right? Another way is known as one-hot encoding. These two are the famous one, and mostly we use this label encoding. Again, depends upon the data. All right, one-hot encoding. It's the basic approach. For I should teach this first, then label encoding I should have taught, but it's fine. What is one-hot encoding? No, you guys told me no, कि you have 4 favorite colors. I'll put color over here. Color. Earlier I was having this data set: yellow, red, blue, and black. Right. In one-hot encoding, what I will do? Oh, okay, you got no how I map the color. See, for earlier in the label encoding, I'm talking about label encoding. Earlier, our data was looking like yellow, blue, red, and black. Earlier data, and we just encoded it to like this: color 1, what is yellow, blue, red is 3, and 4. This is our updated value for the same column, right? This is old, this is new. The same thing, what we will do to understand, now we will train the model on this data, the new data, because it is now in numerical format, right? So for the one-hot encoding, what we do, we create our data like this. We'll get the values, okay, what are the values over here in that particular column, as we'll make them as a column in a new data. I'm telling you, new data. I'll map over here, otherwise you guys get old and new. How the new data will look like? It will look like this. Y was one of the value, I'll put yellow over here. Again, red was one of the value, I'll put red over here. Blue was one of the value, I'll put blue over here. Black was one of them, I'll put black. Now for example, yellow, whose favorite is yellow? Let's say I'll take the name Shivam is there. Then again K is, okay, Diya, okay, I'll remove them here, Shivam name. I'll put Diya name over here. Now Diya, and let's say for Shivam it's blue. For red, let's say Rajat or anything. What I'm seeing right now, I'm just putting it. And black, let's say for Amitabh. So Diya, Shivam, Rajat, Amitabh having the value. This is the name value, right? Name, Diya having yellow, Shivam having blue, Rajat having red, Amitabh having black. These 4 are color mapped. So the new data will have name, and the same name over here, what I have written, will be Diya, Shivam, Rajat, and Amitabh, right? Now the point is, for the same thing, what I'll do, what I name took, Diya, Shivam, Rajat, Amitabh. What I'll do, I'll put the name over here also. Name, column, extra column I'm adding. Diya, Shivam, red, and Amitabh. Red, sorry, Rajat. Okay. Now what I'll do, for the Diya, the favorite color was yellow. So the favorite color was yellow for the Diya. I'll put 1. Red 0, blue, black. Because her favorite color was yellow. In the color section, only one value was present, that is yellow. I'll put 1. For the Shivam, the red was present. So I'll put 1 over here, I'll put 0, 0, 0 over here. Because his favorite color is 1. Now red, Rajat is for black. Sorry, blue. I'll put 1 for Rajat, blue in the Rajat row, and for the rest of them I'll put 0. And for the black, I'll put A as black. Aditya is playing with companion mode. I'm getting message. Okay, for Amitabh it was black color, so I'll put 0 for yellow, 0, red, 0, blue, 0, black, yes, 1. This is how it get mapped. For example, a new guy will come, like Aditya right now. Aditya, let's say Aditya favorite color is also red. So how it will be mapped? It will map like this. For the red it will be 1, and rest of them will be 0. So what we do, we make all the column present into this into an category for a new data, and we will assign the value for the rest of the features like this. You got my point? how one hot encoding works? Anyone, any kind of doubt? Okay. This is one hot encoding, label encoding done. Apart from this, there is ordinal encoding. Ordinal encoding is similar to that of our label encoding, but it is mainly used for like when we have a meaningful order. What I taught you right now, no? Where is my pen? Huh. Good, bad, sorry, good, better, best. So once you give a meaningful order, like one for basic, two, okay, two is a higher number, so I'll give it for a higher category. Three is higher, I'm giving for higher category. Meaningful order once you add, that is known as ordinal mapping. So we learned about three, that is label encoding. In label encoding, you can assign anything to anything, any number to any category. Okay, but in ordinal mapping, what we do, we prioritize or we have a meaningful order. Okay, for good, I'm assigning one. So good is better is good than क्या मैं बोल रहा हूँ? Better is a higher category than good, so it will be having a high value. So let's say bad was there, so bad is a low category than good, so it should have zero value. This is how ordinal mapping works. So three types of encoding. Sorry, not mapping. You can put encoding. Mapping is also fine. Mapping or encoding. There is nothing difference between mapping and encoding. Mapping we do by our hand, like own we do mapping, and encoding is done by some what do you get modules. That is the difference. Mapping we decide which category will have what value. Encoding automatically defined as per the alphabetical order. That is the difference between mapping and encoding. This is one of the key points you should remember. I forgot. Mapping and encoding. Mapping and encoding. Mapping is for when we assign the values. When we knowingly assign, okay, for this category we are assigning this value. And encoding is when we use modules. Modules are nothing but packages or what like NumPy and Pandas. That is Scikit-learn. For encoding, we use Scikit-learn, Scikit-learn. So when you use modules to map as per alphabetical order. That is encoding. I think I gave a lot of content today, a lot of new things you guys might have heard of. Do you guys want me to stop over here or should I continue? Put a thumbs up if you want me to continue. Okay, then I'll take a test also tomorrow. Okay, if you guys don't answer, no, I'll do something. Sorry, I didn't get. Okay, let's continue with the part. There is something. Why I'm teaching this, because at the time of model development, no, these are the basic stuffs of machine learning engineer should know. So, feature scaling is done. Feature transformation is not done. I think so. No, feature transformation is not done. And one more topic is left. That is feature selection. Somebody put something. Feature selection. What is feature selection? Okay, let's say I want to have a football team for the intra-state championship, right? Football team for intra-state championship. Let's remove this I. Okay, football team. FB, not Facebook. This is football. Okay. So football team for intra-state. And what we have right now, how many students are there? Let's say 21. So out of 21 students, I want the best person who can play the football, right? Who can play football very well. So out of 21, let's say these are some students. 6, 7, 8. Let's say how many? 2, 4, 5, 3, 8. Let's say total students are 8. Okay. And for the 8, what is the point? Okay, let's say this guy plays football very well. This guy plays football very well. This guy and this last. So I got 4 students, but these 4 students, the rest of the 4 don't know how to play football, right? So what I have to do, I have to select these 4 for my football team. Right. This is the concept of feature selection. Because in our data set, what I have shown you right now in this, no, in this, you have seen there are multiple features, around 17, 18 features were there. Okay. So this out of this much features, I just want the important one, which is important for my chess prediction model, chess playing model, right? Which can predict the next move or whatever the part says, the win or loss or something like that. Okay. For example, I got another best example, not best, better example. Okay, let's say I want to create a heart disease prediction model, right? And in that, if I am asking your CGPA in undergraduation, okay, then tell me how much, like, how many countries you have visited. Okay, do you go to your classes regularly? Have you bunked your classes in the university level or like undergraduation level? So these are the useless thing, right? Which doesn't create any impact for our model training. Right, for the human disease prediction, human bol raha hu, heart disease prediction model, for that these are the useless features, right? Same way, but it can be used for some other. Let's say if it was student depression, no, over there this matters. Slightly it matters, but matters. The same way, we will select what is feature selection means. We'll select only the useful features. Over here, the useful features are these for the football selection team. From our data set, we'll select only the features which are actually meaningful for our model training. Now, just understand this part. For the football team, we can give them a football and we can tell them, ki, okay, now play. So we can judge on behalf of their skill of playing, right? So how we can judge the features, because we can't tell them to play, right? So there are multiple tests. For some of them are chi-square test or like ANOVA, ANOVA test, which helps you to describe the feature importance. Like how important for this, let's say this guy don't know how to play, so the importance in the football team is very low, 0. This is okay, he plays but he don't know properly how to goal, that is 0.1. But these four smart guys have 0.9, 0.95, something like this of the importance. The same way, those features with a higher importance will be selected, those with the low will be removed. That is known as feature selection technique. This is comes under when we want to increase our model efficiency or model accuracy. Sorry, not efficiency, accuracy. Efficiency also, it also increases efficiency, because as you reduce the number of features, your model don't have to waste extra time to finding the pattern in particular column, such that okay, this is the one of the key feature which is going to predict the output of the model. Okay, so that is the main part. That's why it increases the efficiency. Also, it also increases accuracy, because now you don't have to extra wait for these guys, no, because they don't know how to play, their importance is very low, that is 0. So why you want to get the input for this? You don't want, just remove them. That's the part. You guys got the point of feature selection? Any doubt? See, everybody means everybody. You should put a thumbs up. You are not this much lazy, you can't put a thumbs up. I'll check everyone's screen. I'll take a screenshot also. Okay. Okay, meanwhile, this is another way of taking attendance. No? Yeah. एक तीर से दो निशान. Okay. Okay. Okay, let's continue. The last topic from the feature selection part, feature engineering part, where we will end our feature engineering topic, is what I forgot. Is creating new feature. Yeah, creating new feature. Okay, I'll take the same example. The football team. All right, but slightly different way. Let's say we have 8 candidates, right, for our football team selection interview or like selection process. 2, 4, 6, 7, one more, 8 guy. And again, he is the best. We are selecting this guy also, this guy also. Okay, right now we are selecting only 3 guys. for the football team. But the point is, okay, this guy is overall better. He's having importance of 0.9. This guy also having 0.8, 0.95. That's why he is inside the team. But the point comes over here, no? Okay, this guy is around 0. No, not like this. थोड़ा अलग तरीके से. Let's say this guy can run fast. This guy have good aim precision, right? And this guy know defending, and this guy knows shooting only. Like this guy is run fast, only runs fast. This guy have good aim precision. Aim means he can goal very easily. This guy having a good defending skills. This guy have only shooting skills. But they are individuals, right? They are not complete. That's why they are not inside the team. And one is the useless fellow, like this guy. This is the useless fellow. Okay. So what we'll do? We will merge them. Okay. I'll do the something unusual. I'll merge this, and guy, and I'll create one person out of 4 of them, those who have all the 4 qualities. Right? Are you getting what I'm trying to say? I'm merging all the features of all the 4, like these 4, they're unique features, and I'm getting one feature. Okay, now this person will having a good shooting skill also, good defending skills also, good aim precision also, and good running, like he runs fast also. So now this person will have more, this can now eligible, no? This has more feature importance, let's say 0.99, because it's performed for all skills. So now its feature is more valuable as it is now more valuable as compared to the individual ones, right? Any doubt till here? Guys, do you have any kind of doubt? Okay, so I'm proceeding with this. That's how we create new feature. What we do, we merge some of them in unique way to create one feature which have much more importance as compared to the individuals which we have used to merge. How we do in real life, for example, you have a data set of again agricultural land, and in that one of the column is your length, another column is your breadth or width, sorry, whatever you want to put, you can put length and width. So you have some values for this, you have some values, and multiple columns are there, and some distinct values for it. What you saw, length alone don't have much importance, and breadth also don't have much importance. But if you combine both of them, that is length into breadth, you got one more feature known as area. Now what you do, you just replace both of them with the area. Remove this. You just put area on it. Area. Now this has much more higher value as compared to length and the breadth feature alone. Right? This is known as creating new feature. Like same for the BMI also, body mass index. Okay, so if you have height and if you have weight, so individually height doesn't matter, individually weight doesn't matter, but a BMI of a person too much matters when you are talking about glucose level or like sugar test. Right? These two features individually doesn't create a huge impact. Yeah, weight have some impact on your blood level, but height doesn't have that much. But once you combine height and weight, you get a new feature which has more importance as compared to weight. Weight was having 0.5, it is now having 0.8. That's what is known as feature combine or feature combining new feature, creating new features, combining features. Okay, any doubt till here? No, something is more left. I created PPT. I'll finish PPT. Yeah, sorry. So this is dataset in tutorial. Dataset is in the void. So you need feature scaling, data selection, exploratory data analysis. This is one of the example. And yeah, model training. I'll take more 5 minutes. I'll finish it off. I think so. I have just one more slides. That's it. So model training, where alarm take to make accurate precision parameters. See, I told you, weight and biases, that is the equation of the part. Something is known as a loss function. I'll tell you what. this last concept, such that it should not be if you don't cover it today, no, it will become burden for tomorrow. I gave you one dataset description like this, no? Okay. This is the part over here, over here, over here, over here, over here. And this is the cross. And we gave some values. Let's say this is one of your model. This is your model line. Model line. There is no word known as model line, but okay. Okay. So what I gave some features to the model. Features. Some like I'm testing on some unseen data. I'm testing my model on unseen data. I gave some values to it. It gave me some output. How it output? Let's say this is the part over here. Okay, but what is the point? Okay, this much of distance. Like this part comes on the left side. Okay, fine. But at what distance it is coming? Let's say 0.5 centimeter or something. So does actually I am giving some unseen data, but I have the output for it somewhere else, like for the blood test or something, which I have already done it. So I have the output, and this is it is also giving me some output, right? So what is the difference between this output and the main output? Where it should be? This is known as the difference between both is calculated by loss function. You can read the definition. A method for the difference between the model's prediction and the actual outcome is known as loss function. And jitna kam loss function ka hoga, the goal is to minimize the loss function. So see, if it is at the distance of this, but it has to be distance of let's say this. It has to be at a distance of this. So if you can reduce the loss function is nothing but the distance between this. If you can reduce the distance, let's say this is right now 0.5 or 0.4. So you have to reduce. So you have to make your model more better, right? So as much as the loss function, the more better your accuracy will be. And optimizing algorithm is nothing but which is used to minimize the loss of a function. You guys can read it. I'll share this to you also. And this is the last thing: model overfitting, model underfitting. Okay. Model overfitting means I gave you the example, right? The same thing. Okay. If you want your model to classify. So, yeah, I got this is the better example to tell overfit and underfit. Say if this is x. This is x. Sorry. X. And there are multiple x over here. So your machine should able to cluster them, right? Okay, this is one of the pair, and this is another pair. Like these two are the same, and this is another third pair, right? But what it is doing, this is how the normal. I'm telling you about the normal. But what is overfit? I'll tell you overfit. I'll copy paste it. Better I'll copy paste it. Over here I'll tell you what is overfit. Overfit means your model, let's say if you are putting a basic classification model, so it will look like this. This is overfitting. Like you are trying to train the model based on each and every possible output. Okay, this is overfit. What is underfit? How underfit look like? Okay, underfit. Underfit means, okay, opposite to this, I don't care wherever the line is. I don't care like that part. So there are multiple values coming, this also and this also. Okay, it can produce some this 0, 0, 0 also over there, but this is underfit. And what is the exact model should be doing? The best model is this. The best model should be doing like this. This is still, oh, it's fine. Or you can do, पहले तो इसको ओ करो. This is the best. You got the difference between overfit, underfit, and best. The better way to visualize is this. Overfit मतलब हद से ज़्यादा, enough excess enough. Underfit मतलब to the point and each and every skin it is getting attached with. And normal is how we guys are wearing. If you are wearing this too, so I can't help you, but yeah, a normal person wear a normal jeans. So this was from my side, guys. Sklearn was also there in today's topic, but if I continue with that, it will be 1830 or more than that. In my notes, what I will say, there will be Sklearn part also, Scikit-learn. Okay, so no need to worry. Scikit-learn will cover whenever I'm teaching you the machine learning models. No, at that time I'll give you Sklearn brief. This is the basic library which is used to import the machine learning algorithms. That's basic meaning of Scikit-learn. Means every machine learning algorithm is present in the Sklearn library. You just need to import it. You don't have to hard code anything. You just have to give the parameters values. That's it, done. That's why Sklearn is used for. But its spelling has Scikit-learn. So this was from my end, guys. If you guys have any kind of doubt, don't ask me. Means you can ask me, but yeah, okay, you can ask me. Okay, go ahead, ask the doubts. Till then, those who want, yeah, just a second, Siva. Those who want to leave, classes ends over here right now. I'll not teach anything else. If you want to hear somebody's doubt and their answer, you can stay, else you can leave. And tomorrow class will be on NumPy or Pandas by Jaypriya. Tomorrow class is not mine, so I'm gonna chill. Okay, guys, now you can ask your doubt. Yeah, Shivam, you are having doubt. Huh. Yes. Yes. Yeah. Feature scaling. Huh. Huh. Okay. Uh-huh. Bro, put your mic little bit far, bro. It's too much. I reduce the volume, but yeah. Okay. See, now you can ask the question again. If it is a exponential or like it's a very big data, then yeah, tell. Huh. Okay. Ha 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 ha. Correct. There is a known as there is a different method I didn't cover over here. That was Z score. Z score scaling. Okay, where you have if you have a lot of data that doesn't matter, but you can just use Z score. It's having a formula. I forgot x naught minus x by mean something is there. It's x minus z naught something. Something is this. Some formula is there. That is used to do for a large data. When your data is too much big, no. So in that case you can use where the mean will be 0 and standard deviation will be 1. Like your data will be 0, the mean data, and you can go for the negative value also. You'll be getting while scaling. After doing scaling, you'll get -1 also till 1 also. So right now we are using 0 to 1, right, in this part, but dividing by this. That is normal min-max scaler. But over Z score, what we do, we use a formula. I forgot the formula. It comes under probability and statistics. In the third sem we have. So in that, every data point will be distributed -1 to 1 with whatever the exponential growth, it will be fitting very well. That's why Z score scaling method is there. Something it look like this. I should switch off the